Here's pre-calc. Well, I guess it's your lecture for 5.1.1. I'm just going to do problem 5-1. It says, in this lesson, you will review multiple representations of exponential functions. You will apply your knowledge of exponential functions to everyday situations. So 5-1, multiple representations of exponential functions. Each situation below can be modeled with an exponential function of the form y equals a times b to the x. For each situation, explain why an exponential model can be used and create multiple representations like a table, graph, and equation. For each situation, before moving on, verify that each representation for the situation is equivalent. It's going to take a long time to do all these, so I might not do the graph and the table and the equation. I'll do all the equations, but just to save time, I'm going to go real quick through this so it's not a 20-minute video. So this says Romel has saved $4,000 and plans to invest it in an account earning 5% interest compounded quarterly. Assuming no further deposits, how much money will Romel have in the savings account after T years? So I already have a formula for that in my magic book, and it's compound interest. And you can find this just by Googling. It's the amount is calculated by having the principal multiplied by the sum of 1 plus the rate over n raised to the n times t. And so we could just plug all the numbers in here and get the answer, and that's fine, I suppose, but I guess we're going to spend just a couple moments trying to figure out why is that the formula. So let's get it. So Romel, he saved $4,000. So even if I didn't have this compound interest formula, I could kind of imagine 4,000 is like the starting point. And then it says, what else does Romel have? He's getting 5% interest. So my rate would go right here. But it's not just going to be 5%. And by the way, let's find out what 5% is. 5% would be 0.05, wouldn't it, as a decimal? But if I put a rate in here of 0.5, I'm going to just get less and less and less money, if that makes any sense. Because I'm counting I want to see what accumulates, like I want to count that 4,000 that's already there. My rate's going to be 1.05. And that's because I could do the 0.05, and then I could like repeatedly keep adding it to the principal. But I can take care of all that just by adding this 1 here. So, but I can't just plug that right in for B, because there's this compounding thing that is happening. It says here, it's a little more complicated. It says it's compounded quarterly. So that means in 1 year it's going to get compounded or calculated 4 times. Okay, so how are we going to deal with that? So we're trying to figure out what kind of goes right here, and for B, we got that we're going to take the 5%, but we have to add 1 to it so that it'll account for the money that's still accumulating in there. And then I can peek over here and see that we've got 1 plus the rate divided by the number of times it gets compounded. So let's start working with that. So actually I shouldn't have added them together yet. So the rate is 5%, but I'm gonna kind of spread that 5% out because I'm going to do my calculations 4 times each year. So I'm going to put the 4, and that I got that from because it said quarterly. And then since that little calculation has to happen 4 times a year, I'm going to go 4t. Okay, then I could just make this be A for amount. And then I can just do all the math. Are we supposed to calculate the whole amount? Let's see. I think it just wants the formula. So, and can I fix it up at all? Can I like simplify it? I could put some of it in my calculator. I guess I will put some in my calculator. So I think I'll find out what 0.05 divided by 4 is. And then I'm going to, so I'm just calculating this piece right here, and then plus 1. That's 1.0125. And then the book was saying, no matter, you know, all these 4 situations are going to be, you're going to be able to get them into y equals a times b to the x form. And this kind of is almost in y equals a times b to the x. It's just got, it's got that 4 there. But the law of exponents says I can just move the 4 into the inside. And the only reason I would do that is just because the book is kind of asking us to put it in exponential form, like graphing form. I can leave it like that. I could actually get my calculator and find out what that number raised to the 4th power is, but I don't really want to because of all the decimals and the rounding that's going to have to happen. But you can, the book does actually, and I'll show you how. You have to say that it's rounded once you do that though. So your book has it like, they just stuck it in the calculator. That's the number you get when you raise, that's the rounded number that you get when you raise 1.0125 to the 4th power. You get that. And then I'll do just a very quickie little graph for this. So a quickie graph would be, maybe I'll do a quickie table with it. I usually like to just plug in some very easy numbers like 0 or 1 or something. So if I look at maybe this one, if I plugged in a 0, that would just give me 4,000. And we know that's the starting point anyway. So we'll just say this is 4,000 on my table. And I think it's going to be going up. And if I put a 1 in here, so I've got this number but not rounded. And then I'm going to raise it to the 1 power. Well, raising it to the 1 power, it's still going to be its same number. And then I'm going to times it by 4,000. I don't know. I'm just going to show it as, I can see from my table that it's going up. It's an increasing function. Okay, so really, honestly, you could have just plugged, if you know that it's a compound interest problem, you can just put that, get that form, get this compound interest formula and just use that. But you could also kind of logic it out and get it into the exponential form. Okay, that's actually 9 minutes gone by, so I think I'll do letter B on a different video.